last session, we started with neural machine translation. It had the problem set up, how the data is going to look like, what type of models we usually use. It even had a little bit of attention. It also gave us what performance metric is a good one to use. It's not the best one, but it's a good one to use when it comes to measuring the performance of machine translations. Then we said we are going to remove attention mechanism for a while just to appreciate it. So we removed attention mechanism, but then we had to reverse the order of our input sentence. We also noticed that it's a good idea to go deep, not only in time, but also in the space. Then we noticed that neural-based machine translation systems are not able to beat the baseline. And then we asked, what if we use neural-based machine translation framework to actually help existing machine translations or statistical translation techniques? One idea was use your baseline system to give you 1,000 candidate translations and then rescore them. Use your neural network to actually rescore those. And then that way, you're able to improve the performance of your baseline system slightly. Another idea was, rather than doing the rescoring framework, what if you add the output of your neural network as additional features to your statistical machine translation technique? So you have some hand-engineered features, you have some learned features from your neural network, concatenate everything together, and then learn a linear model on top of everything. And then that idea was also working. And then this figure is just showing us that actually the features that your neural network learns are different from the feature that we had engineered before. But up until this point, the message is that a neural network machine translation system is not going to beat statistical machine translation techniques on its own. And that's why we're going to move to this paper. This is a good paper in the sense that it is going to ask the right questions. And once you ask the right questions, then the rest of the literature is going to try to solve those problems. The observation is that neural machine translation systems are not going to beat the state of the art on their own, at least in 2014. The questions are, what could be the causes of them? And then this paper is going to point out two problems. One is that the sentence length matters. The other one is that vocabulary size matters as well. So this is an assignment for you to watch that video. If you're interested in more details, I'm going to go through this paper, give you an overview, and then you can ask questions. So this session is, whenever we have a video up there, it's most of the times Q&A. So make sure that you're asking questions. The paper is going to introduce a new architecture, but we don't really care about that architecture. It is based on a gated recursive CNN type of architecture, which is going to take into account the semantics of a sentence, or it's able to learn or pick up the semantics of a sentence on its own. And it's based on CNNs, and you have some gates. And whenever you have a gate, you're pushing a linear combination of your hidden units through a softmax or through a sigmoid. And sometimes the gate is going to be open, sometimes the gate is going to be closed, depending on the value of your output, your gate. But that's not the point. The point is, let's study two different architectures, one of them being RNN-based, one of them being CNN-based, and then study these two effects. What is the effect of the size of your sequence, and what is the effect of the size of your vocabulary on the blue score? And that's why having a score is really important, because it's going to enable you to summarize the performance of a machine learning algorithm in a single number. So let's study the sentence length. For small sentences, your blue score is going to be low. For moderate size sentences, the blue score is going to be high. For both of these models, for RNN and this GRConv, which is gated recursive convolutional neural network. So for two different models, you are seeing the same observation. For moderate size, your blue score is the highest. And then as you increase the sentence length, the blue score goes down. It means that the quality of the translations coming out of these two different systems is going down. So the longer the sentence is, the lower is going to be the quality of your translation. And this could perhaps, for RNNs, one reason could be you're actually forgetting. There is some vanishing gradients. Even if you use LSTM or GRUs, there is going to be some forgetting going on. The longer the sentence, the deeper is going to be your architecture, and therefore you're forgetting something by the end of the translation. But you see the same observation for CNN. So the problem couldn't be RNNs, or the sentence length has nothing to do with RNNs forgetting stuff. Maybe it has to do with how, in a long sentence, the order of the words are going to change from one translation to the next one. And to resolve that issue, we are going to introduce back the attention mechanism. And we are going to see that, yes, attention actually fixes this problem with the sequence length. The other observation is the more unknown words that you have in your sentences, the lower is going to be the quality of your blue score or the quality of your translation system. And it makes sense. The more words are in the bucket of unknown, then we are not going to know what unknown is going to correspond to the correct word when it's going to get translated. One solution is to just copy and paste. If you have any unknown words in your English translation, just copy that unknown word to the translation directly. And that fixes this issue to some extent, but this still exists. The more unknown words, the more problems you have when it comes to the quality of your translation. Any questions? Was everything clear? Okay, perfect. So sometimes asking the right question is much more important than finding the answer. And this is asking the right questions. Sentence length, vocabulary size. We are going to fix sentence length issues with attention, and we are going to fix vocabulary size with byte pair encoding.